Hey folks, we're going to be talking about electrolytes and hygroscopic compounds and all sorts of stuff today. So make sure you have a pencil ready. You're going to be taking a lot of notes on what a lot of things are. Okay, you're going to write down a bunch of definitions. Alright, the first one's an electrolyte. An electrolyte is a compound that conducts electrical current when it's in a solution. So you'll notice the electro up here. That means electrical. It will conduct electricity when it's in solution. And dissolved ions are required to conduct electricity. So you've always heard from people that water conducts electricity. Not true. Water does not conduct electricity well at all unless there's something dissolved in it. Then it is a wonderful conductor of electricity. So especially if there are ions dissolved in it, like salt. Okay. So I'm gonna step away from this. I'm going to let you watch a video for a minute, and it really explains and demonstrates to you a lot of different items that are and are not electrolytes.
The term electrolyte is a term used when talking about solutions with water as the solvent. We'll demonstrate the property of being an electrolyte with an electrical conductivity tester like this. Pure water does not conduct electricity. I will put the electrodes of the apparatus into the beaker of water. There's no light coming from the light bulb. If I dissolve a material in this water and the light lights very brightly, the dissolved material is called a strong electrolyte. As an example, here is a small amount of table salt. I'm going to add just a little bit to the water and stir it up. As it dissolves, the ions of sodium and chlorine, which are charged particles, go into the water, which will now allow the solution to conduct electricity. So the ionic substance, table salt or sodium chloride, is a strong electrolyte. The term non-electrolyte refers to a substance which dissolves in water but does not allow electrical conductivity. Here is some sugar, which I will dissolve in the water. As the sugar dissolves, the light does not light up, so sugar is a non-electrolyte. Some acids and bases are also strong electrolytes. Here's an example of some hydrochloric acid. Only a little bit in the water, and about 10 drops will allow the light to light up very brightly. So the acid is also a strong electrolyte, therefore it's called a strong acid. Acetic acid, on the other hand, dissolves but allows very little electricity to go through the water. See how the light bulb gives off much less light with a lot more acid. Thus we call acetic acid a weak electrolyte, and it is a weak acid.
Alright guys, welcome back. That was kind of cool. A compound that conducts electrical current when it's in a solution is called an electrolyte, and dissolved ions are required. So as you saw in the video, water does not conduct electricity, pure water, but as soon as you put some salt in it, it conducts electricity really, really well because salt has dissolved and you now have dissolved ions that will conduct electricity. Now sugar does not dissolve into ions, so it is not an electrolyte. Right? So sugar dissolves, but it will not conduct electricity. So it's not an electrolyte. Other things are alcohol, benzene, ether. There are lots of things that are not electrolytes when they're in solution. Right? There are some things that are strong electrolytes, like salt, hydrochloric acid. You saw both of those in the video, because they both completely dissociate in water. Now there are things that are weak electrolytes that don't dissolve completely, one of which is acetic acid or vinegar, because it does not completely dissociate in water. So only a few ions are available to carry the charges. Another example would be benzoic acid. Okay, not important. What is important is that you understand the difference between a strong electrolyte, a weak electrolyte, and a non-electrolyte. That's what you have to understand. Alright, we also have another term called a suspension. Now, down here you see all of this muddy water down here. Alright, there's mud suspended in the water. Now what would happen if we took that water, put it in a glass, and just let it sit there for a week? Would the mud stay at the top, or would it all settle out? Okay? Well, the bottom line is the mud would settle out. And the mud would settle out because they're rather big molecules of dirt. Okay? So a suspension, by definition, is a heterogeneous mixture, and it settles out over time. Muddy water is a perfect example. It differs from a regular solution because the particles are larger and they don't stay suspended. So if you think of vinegar, which is yellow, or you think of Dr. Pepper or Coca-Cola, which is brown, they never lose all of their color, and all the color goes down to the bottom and it becomes a clear liquid up on top. It just stays that color all the time. Okay, so those particles are really, really small, and so they stay suspended. All right. So an example of suspension would be dirt in water, or clay in water, cornstarch in water. These can usually be separated by filtration. So that's a suspension. Now there are other things called colloids, which are kind of in between suspensions and regular solutions. So if you think of a colloid, Elmer's glue is a great example that you're familiar with. This is some shampoo, and if you look carefully at the shampoo, it looks kind of milky, so you can actually see stuff in it. And if you look at a lot of toothpaste now, they're gels, and some of them even have little flakes of stuff in them. All right, gels are good examples of something called colloids. All right, and a colloid, the particles are smaller than in a suspension, but they're larger than solutions. So they do not settle out over time. So it's still heterogeneous. There's still multiple stuff in there that you can see. They look cloudy, but the particles are so small that they do not settle out over time. They're able to stay where they are. So that's the definition of a colloid, and that's how it differs from a suspension or a solution. All right, switching gears a little bit. You should know that vinegar and oil. Try that again. Vinegar and oil don't mix. So here we've got some oil, here we've got some vinegar. You put them together, you shake them up. They'll look mixed for a few minutes, but then you just let them sit there for a while, and the oil's going to end up on top, and the vinegar is going to end up at the bottom. Okay, so they do not mix. All right, but what happens if I take an egg and throw it in there and mix it up? Well, the egg yolk is what's important, and we come up with an emulsion. So mayonnaise, what mayonnaise is, really, is it's vinegar, and it's oil, and it's egg yolks. And you mix them together, and you get something called an emulsion. So an emulsion is two liquids that form a colloid in the presence of an emulsifying agent. And in the case of mayonnaise, the egg is the emulsifying agent. So it's just vinegar and oil, which normally don't mix, but if you add the egg yolk, they will stick together, and they will not separate over time. So that's the colloid. Again, if you look at mayonnaise, you don't see a layer of stuff at the bottom and a layer of stuff at the top. That would be really gross, right? So mayonnaise is just this white substance that's all together, and it's called an emulsion. So you should write that down. All right. There's something called the Tyndall effect. And the Tyndall effect is if I take a solution, which is going to be this one on the left, light will pass through a solution. All right, so light will pass through this solution, but that same light, when it hits a colloid, will not pass. Well, it will still pass through, but it will be dispersed here. So what does that mean? Well, the particles that are in here, which are very, very small, but and they are staying suspended. All right, but remember it's heterogeneous, and they're constantly moving around. And when they move around, you can see and they're bigger, so when the light hits them, the light reflects off of them. So what you're seeing is the light beam, which is coming out of here. The light beam is going over in that direction, right? And when that happens and it hits the colloid, it disperses the light. So that's what's called the Tyndall effect. And that's how you could tell the difference between a solution, for example, and a colloid. Now, when you look at the air, sometimes in the morning there'll be a lot of moisture in it, and when the sun comes through it, you will actually see the moisture in the air. Right? More commonly, you might see smoke in a room. So, if someone's been smoking in a room, and you have light coming through the window, it will be bounced off of. It'll reflect off the smoke, so you'll actually see the smoke particles. Very often you'll see dust particles. That's another thing. Those are a little bit bigger. That's really a suspension. but you'll see the dust particles floating around, and you can actually watch the dust particles move around in the room when the light streams through the room like this, which brings us to Brownian motion. Watch the dust. The molecules are constantly moving. Now, it's not because you're blowing on them, and it's not because the air conditioning is going in the room. You can have it so that there's no air conditioning in the room. But the molecules in the colloid are reflecting the light in different patterns and directions, and the molecules are moving because the air is constantly moving. The molecules are constantly moving around, and they bounce the dust particles all over the place so that you can actually see them. All right, another term that you need to write down are hygroscopic compounds, and they're salts that remove moisture from the air. You've often seen them when you buy a pair of shoes or when you buy an electronic product. Often you will find one of these packets sitting in with the shoes or in with the electronic product, and what they're doing is they're sucking up the moisture, and they have this word on them called desiccant. All right, and a desiccant is something that soaks moisture up out of the air. So they're also called deliquescent compounds, and they So hygroscopic compounds are called desiccants, and they remove moisture from the air. They will suck moisture from the air. Now, if you have something that sucks lots of moisture from the air, you get something called a deliquescent compound. And it is extremely hygroscopic, so much so that it pulls so much moisture out of the air that it gets wet. Now, the silica gel, if you look at it, never gets wet, right? But there's some compounds like sodium hydroxide that will get wet when they just pull moisture out of the air. And they'll get so wet that they dissolve and they form a solution. So if we look at sodium hydroxide, over here when they're first pulled out of the bottle, they're completely dry, right? And they're just little pellets of sodium hydroxide. Another way to look at this is lye or Drano, solid Drano, if you get some of that. Now if you take some of that and you leave it just sitting out, please don't let it sitting out on a counter, but in a petri dish, for example, because it's glass, right? You should be able to see down here that there's actual water on and now collecting under these pellets. Well, now the water that's collecting under them, of course, has dissolved sodium hydroxide in it. So this is a very strong base, but they are getting wet. All right, so they are absorbing water from the air. All right, folks, you got a lot of words to be familiar with, right? So we have lots of words, lots of terms, okay, and these are all terms that we use when we're talking about solutions, so you need to be familiar with them, okay? Go do the worksheet. We'll see you in class. Take care. Bye-bye.